Okay, hey, fifth and sixth period, and anybody that was absent on Thursday. Here's just a brief overview of correlations. We talked about correlations at the very beginning. Standard one is about the different kinds of research methods. So we talked about the descriptive methods, which are surveys, naturalistic observations, and case studies. Okay, and that's where you're collecting lots of data. And then we talked about correlations, which are where researchers compare two different variables. Then the third one, or the fifth one, is experiments, okay? And we did standard two, which was all about experimental design. So kind of understanding how experiments work and the need for operational definitions. So today we're going to talk about standard three, which is just correlations, and go a little more into detail so that you understand how they work. And then you've got to learn about scatter plots and some other things, okay? So let's take a look at this. Why do we use a correlational study? Sometimes you want to study something that you can't ethically do an experiment on. And so if it's not ethical to manipulate the independent variable, then you'll use a correlational study. You'll also use them at the beginning of a research project sometimes, just to see if there's a relationship between the variables, and make sure that there is a correlation before you go on and spend the money and the time to do the bigger experiment. So that's a couple of reasons that you would use them. Something that's not ethical, we talked about the idea that if you want to study the impact of smoking on a teenager's lung capacity, it's not ethical to have teenagers smoking and then that's what we manipulate and then test their lung capacity. So you can't really do that. So you can study teenagers who smoke, and then you can see if lung capacity increases or decreases. It's not a cause and effects because you didn't manipulate a variable, but you're comparing the idea of smoking with lung capacity, and that's a correlational study. And so it's useful because if you can show that correlation between smoking and lung capacity, that may be enough to convince teenagers maybe shouldn't smoke, okay? The same is used, you see studies about football players getting CTE or, traumatic brain injuries. And so, that guides parents, do you want to let your kids, play football? And so those are why we would use correlational studies. Honestly, you see a lot right now when you look at the like the COVID stuff and wearing the mask. There really hasn't been enough time to experiment, and is it ethical to experiment on whether masks protect you from COVID? So most of those studies you see reported as fact are really correlational studies. So as you read results of studies in the newspaper and things like that on Facebook or wherever you look, you want to think about it. Is this really something that is a cause effect? There's been an experiment, or is it a correlational study? And so just keep that in mind. Also, with correlational studies, as you see descriptions of a correlational study, and you have to figure out what kind of research is going on, usually in correlational studies, you'll see that the researcher is looking for a link between this and that, two variables, or some kind of relationship, okay? If the researcher is trying to prove cause and effect, it is an experiment. But if they're looking for a link or relationship, then that's going to be keywords that tell you, okay, this is a correlational study. Remember, correlation does not prove causation. I can't say it enough. The only way to prove causation is through an experiment. You have to manipulate the variables. In correlation, there's no manipulation of variables, so you can't use it for a cause and effect. We're just looking at the relationships between the variables. Okay, on the next slide is a video for correlation, and this lays out everything you need to know about correlation. So I want you to pause my video and go watch this video. It teaches it much better than I do. So watch the video, it explains correlations, and the next part of my video is not going to make a lot of sense if you haven't watched this video. So it's not going to give you enough. But if you watch this video and then you come watch the end of my video, then you'll be just like we did yesterday with the other classes. So I know it's making you go into the PowerPoint is a little frightening that you won't do it, but please do it because this is really good and explains correlations really well, okay? So pause here and then go watch that video and then come back. Okay, welcome back. So you've watched the video about correlation and it's explained to you. I want to show you a couple of things. When I see a positive correlation, so a positive correlation just means that the variables move the same direction. As one variable increases, the other variable increases. As one variable decreases, the other variable decreases. It doesn't matter if it's an increase or a decrease. If your variables are moving in the same direction, it's going to be a positive correlation. Students get confused and they'll miss it. They'll miss the it's like trick when they think when both variables go down that it is a negative correlation, and that's not true. For it to be a negative correlation, your variables move in opposite direction. One goes up and one goes down. I'm having trouble with it showing my hands here. When I do these correlations, like even as I read them, I literally move my hands, okay? So I'm like, okay, this one's going up, this one's coming down, that's a negative correlation, okay? This one's going up, so is this one, that's a positive correlation. And I think that's very helpful to you if you just kind of move your hands as you do it. I see kids do it during the test. I'm like, yep, you're gonna get these right because you're moving your hands. So a positive correlation, like the more carbs I eat, the higher my weight goes, okay? The less carbs I eat, the lower my weight. That is a positive correlation, no matter what way you're moving up or down, right? When you're showing a positive correlation, it's gonna have an R value of 0 to 1, okay? That's a positive relationship, so that the positive number, it's not good or bad, it's just that there's a positive correlation, okay, 0 to 1. A negative correlation is when the variables move in opposite directions. So we have here screen time versus grades. The more your screen time goes up, the more your grades go down, okay? And so that is a negative correlation. So when your hands move in the opposite direction, that's a negative correlation. When you see an R value of 0 to -1, that just indicates it's a negative correlation. It doesn't mean bad or good. It just means there's a correlation and it's negative, okay? So correlations, you're only going to see correlation values, R values, from 1 to -1, okay? There's nothing above 1 or -1. So if in a multiple choice question it says which is the highest correlation and it has the option of 1.25, well, they're faking you out there. Don't fall for it because no correlation will be over 1. So if it's -1.1, no correlation is below -1. The negative or positive just tells you the direction, okay? Is it a negative correlation or a positive correlation, okay? The number is going to tell you how strong or weak the correlation is. At 0, there's no correlation, okay? As you move closer to -1 or +1, the correlations get stronger. A perfect correlation is a 1 or a -1, and they're equally strong, okay? It's not better because it's positive. It just means it's a positive correlation, okay? And we use these correlations for predicting things, okay? So hopefully you got that. One last thing I want to show you is this website. And let's see if I can get my Flash Player to work. All right, this you can play around with. I'm kind of nerdy. I kind of think it's fun. So I can just set the number of cases that we're tracking. Well, let me clear the scatter plot. All right, there's the number of cases that we're tracking. Okay, whoops, it's not working. Okay, so I'm going to put 400 cases. Okay, that's a lot of dots on my scatter plot. All right, if you see scatter plot, it is a correlation. That's the only thing we use scatter plots for. All right, now if I want to see a positive correlation, a perfect correlation, look. All right, it is in a straight line. All of those dots line up. That tells you it is the variables are really correlated. Positive correlations slope upward, okay? And so that's going to indicate it's a positive. So the upward slope indicates it's a positive correlation. The tighter the line, the stronger the correlation. So if we back it up and we look at a 0.8, okay, 0.7, that's fine. You can see there's an upward slope, an upward trend, but it's not in a straight line, okay? They're bunched on a line. You could put a line right through them, okay? So that means it's a strong correlation, but it's not nearly as strong as a 1, okay? It's positive because the slope is upward, right? If you take it down to a 0.5, you can see it just looks like more of a mess, but you still see a slight upward trend. When you get down to 0, it's just a bunch of dots, okay? So there's no line, no trend, and so there's no correlation. It's just a bunch of dots on a scatter plot. If you go in the opposite direction, you can see that a -1 correlation, again, a -1 and a 1, they're the same strength, okay? It is a perfect correlation. Everything lines up, okay? This time though, because it's negative, it slopes down, right? So you'll have to be able to look at the dots and kind of value how strong the correlation is, okay? And you got to look, if is it sloping down? That's negative. Is it sloping up? That's positive. So keep that in mind, right? So if we look at a -8, that's 6, 7, a -8, you can see that trend down. So that's negative, all right? And then it gets less strong at 0.6, all right? At point 3, you know, it's kind of hard to tell. It's trending down, so, but it's kind of hard to tell. And at 0, you know, we're back to the scatter, okay? So for correlations, you don't have to ever calculate the R value. They're going to give it to you. So if they say the R equals 0.86, you've got to recognize that a 0.86 is a strong correlation, okay? If the R value is 0.2, you have to recognize that that's a really weak correlation, okay? So you have to do that. They also give you these scatter plots, and you've got to figure out what the scatter plot is showing us. At 0, it's a bunch of dots. There's no line. Okay, so that's no correlation, right? But the closer it gets to a line, the stronger the correlation. So you're going to have to kind of recognize that. Sometimes they'll give you like 6 scatter plots, and you'll have to pick the one that's the best. And so you're going to see this as you do the correlational hyperdoc. You'll get a look at the different ones, and they'll be lined up. Okay, but that's basically what you have to know about correlations. I really hope you watch the video, because that makes much more sense if you do. All right, so you're going to go ahead and you're going to do the correlation hyperdoc, and you're going to submit that to Canvas. Once you're done with that, hopefully you'll be done before the end of the period. If not, you still need to do the FRQ practice, and then also the exit ticket. So those may be homework for you. And I know that you're like, but the other class didn't. Well, guess what? We got to watch Mulan, or whatever other movie we watched this period. Oh, Night at the Museum. And they didn't. They worked the whole period. So you gotta catch up. On Monday, we're going to work on statistics. So that's a good day to show up, because statistics can get a little bit tricky for everyone. Okay, so that's the end of the video. Be sure and do that correlation hyperdoc and upload it, and then I will see you on Monday. Have a great weekend.